All right, guys, my name is TJ. I'm the CEO at SupplyPike. My topic I want to talk about was Chomsky hierarchies. I've been thinking about this a lot lately, so I wanted to give a talk to just sort of voice my opinions. How many of, it looks like a very technical audience. How many people in the audience have heard of Chomsky, like Noam Chomsky or Chomsky hierarchies? Anybody? Got to put it in the chat. We could do a poll, but the linguist, yeah, the linguist. So like one person has heard of them. The person. So I'll try and sort of ease into the topic because it is somewhat dense and kind of dry, but I'll try and see if I can break it down. This clicker's not working. So Noam Chomsky, he's a linguist, and he's like a philosopher too. Like he writes a lot about anarchy, and he's a philosopher, and he's like the father of modern linguistics. So like that's a picture of him that was taken like 50 years ago. That's kind of what he looks like today. But he is 93, so I think we can, give him a free pass. But like he is one of the greats. He's a legend. Like if you look at the top cited papers in humanities, like he's in the top 10. Like the people who are in the top 10 are people like Shakespeare and Hume and the Bible. So like among the top 10, like Chomsky is one of the top cited people. So he's made like huge contributions to this field of linguistics. So before we sort of dive into like what he talks about, I think it's useful to sort of define what linguistics is. So linguistics, it's like the study of language. And language is like, I have a thought and I make some sounds with my, vocal cords in my mouth, and it travels through the air to your ears. And you can essentially decompress that sound and recreate the thoughts in your head. So that's kind of like the whole end-to-end of language, right? And this little concentric circles thing sort of like describes each of that process. So if you look at the very bottom of it, there's something called phonetics, which is like deals with the hardware aspect of how the sound comes out. Like how does it sound coming out of your throat and your mouth and all that. And pragmatics is at the very top of that chain, which is like, okay, like the words come out. What do the words mean? What do the words mean in the context of whatever you're talking about? It's like really in like the social sciences realm. But like the stuff that Chomsky's contribution and most of what this talk is going to be about is right there in the syntax realm. It's like we're not going to be focused on like if what we're saying is true or not, because that's like in the semantics and the pragmatics realm. We're mostly focused on the structure and the formulation of the sentence itself. And it's cool because it falls right in that middle of that hierarchy. So it's like the study of thought almost, because it's like how you think and how you structure your thoughts is sort of described in syntax. So it's like the nice sweet spot of linguistics. Next slide. How you doing? Next slide. So, humans have been trying to understand how humans work, like how we work since the beginning of time. And like the dominant theory or the dominant form of thought in the early 1900s was this thing called behavioralism or empiricism. And it's really an extension of sort of the Aristotelian sort of school of thought, which states that essentially you're born into this world as a blank slate and you don't really have any programming in you, and you sort of learn everything through cultural conditioning. So language similarly is not something, it's like something that you learn over time, being exposed to people talking, your parents talking, your friends and culture, and you learn language that way. And that was kind of the dominant form of thought. And this was like, this made total sense because the big leviathans during this time were like Pavlov and Skinner. You guys have probably heard of these guys. Like Pavlov is famous for the Pavlov's dog, which is that if you blow a whistle every time you feed a dog, the next time you blow a whistle, the dog will start salivating. It's called conditioning. So the dog will start almost expecting the food. So it starts salivating without, even if there's no food, it's just a signal causes it to salivate. So, and then Skinner was more operant conditioning, which is you can essentially create new behaviors. So he put like mice in a little box, and he was able to make them do things that they would normally do by sort of giving these rewards, and it would create these dopaminergic circuits in their brain. So you can see how both of them really focus on conditioning. So they essentially thought of humans as like, you just sort of come in and you get conditioned to do a bunch of stuff, and language is picked up. So when Noam Chomsky came, he sort of like really disrupted this this sort of way of thinking. Oh yeah, next slide. Which was what he said was that like language is not something that's learned. Like language is baked into you, into your genes when you're born. So it's like a first level construct. And he like almost describes it like an organ in your body. Like, you know, you have a heart that's like responsible for like pumping blood. Like he almost describes language as like an organ inside you. It's not a real organ. It's just like a part of your mind that he calls it the universal grammar, and it can essentially learn and understand and decode any language. So, and it was like really flipped the thought on its head, because what that means is that you don't really have to go to school and learn all this like formal grammar to be good at writing and speaking. It's like it's inside you, and it's like a spider doesn't have to go to school to spin a web. So it's like that's the kind of evocative imagery he used to like describe this new way of thinking. Yeah, like this image, it's almost like if you come out as a baby, you can kind of like write Shakespeare. It's kind of like the absurd sort of extrapolation of this thought. So that's like in a gist what like the big thing Chomsky's known for. It's like the universal grammar. But we'll sort of dig into more of this here in a second. But I wanted to like make a quick segue into philosophy. I know a lot of people don't really like to talk philosophy because they think it's kind of detached from the real world and doesn't really have any real applications. But when you sort of really understand some of these debates that have been going on in philosophy, it gives you a richer understanding. It's almost like a meta structure to understand the world. So the one thing that like, you know, people have been debating since the beginning of time, like since like 2000, 2300 years ago, that was Plato and Aristotle. So Plato was like, he was like an idealist, you know, he sort of always saw the world. He's like, this is the painting by Raphael. So like he's pointing at the sky to say like there are ideals, and we should always look up to these ideals and try to live up to these ideals. And Aristotle's more of like a realist. He's like a empiricist. He's like, no, don't worry about the ideals. Look at the world in front of you and then make a decision based on the world. Like what does the data say? So like those two sort of forms of thoughts have sort of dominated like most of history, I think. And if you look at it, there's like big personality traits that you can sort of like put in a couple of boxes. And again, just putting in boxes for like examples, you know, people can't really be put in boxes. There's like more of a spectrum. But generally speaking, like Platonists tend to be like more romantic side. They see ideals. They sort of they tend to be more like artistic, and they believe in these ideal forms, and they're more like a software analogy would be that they favor the software realm. It's like mind over matter almost. But the Aristotelians, they really value empiricism and numbers, and the hardware matters first, the mind is second. Like don't live in your head, look at the world around you and let's derive from that. And that really like encapsulates a lot of history, like even philosophy. Like if you look at like someone like Kant would be like a Platonic, while someone like Ayn Rand would be like an Aristotelian. So like with this kind of framework, you can sort of like see how these guys interpreted language. Like Skinner and Pavlov, they were more empiricists. Like they did a bunch of experiments. You know, they put like a mouse in a little cage and figured out what to do with it. The Pavlov studied dogs. But if you look at Chomsky, like he was like a professor in MIT like all his life, like for 50 years, he was just a professor. He didn't really do any experiments. He was just like lived in his head and thought of all these stuff. So this distinction of where the ideas come from is important because it will sort of dive into that. But yeah, let's dive into the actual sort of science behind Chomsky hierarchies. Well, before we dive into that, there's sort of two ways of looking at how to model language. You know, what is language, right? It's just like a bunch of sentences. And what is a sentence? It's just a bunch of words. So it's just a bunch of like words that's strung together. So if you look at this image over here, let me pull it up on my computer. On the left, that sort of shows you like an example of a sentence. So if you start with the leftmost node, it's like the, and then there's essentially like a 10% chance that the next word after the is cold. A 10% chance it's going to be colony, and a 20% chance it's going to be client. And then after you get to that next state, let's say if you go to cold, there's 100% chance that the next word is heart. And then you sort of follow this tree to figure out what the sentence is. And you sort of construct this type of probabilistic tree by studying a large corpuses. So essentially you look at a bunch of text and then you study like the probability of one word coming after another, and you build this tree. So this is, you know, like for the folks who know computer science, you know, it's just like a essentially a finite state automata, or it's like more of a Markov chain, really. But now if you, this is like very limited, right? Like it only has a very limited, like this one only has like 10 words and sort of the probabilities between these words. What if you want like the probabilities of all words, like all of the human knowledge? You want to know for any given word, I want to predict the next word, you know? So like that's kind of what GPT-3 did. Like essentially took the concept of a finite state automata and scaled it up. Like if you look at a finite state automata, it doesn't really have any memory. It's just looking at one word and then sort of like what is the context in the future for essentially the next step. But GPT-3 has like a much larger attention span. It can look at, I think it can look at like around 2,000 words at a time. So it's like a giant sliding window of 2,000 words. So like the technical implementations of GPT is that it's got this sliding window and it's got a massive neural net. It's got something like 170 billion parameters or something like that. And they train it on this massive scrape of the internet itself. It's like a 40, 50 terabyte scrape of the internet that they feed it into this neural net. And then it figures out all the probabilities of the words. And it builds essentially a version of this Markov chain in its mind. So for the sort of the non-technical people, like if I were to explain that, essentially, if you want to build this probabilistic tree, instead of trying to code it all up or typing in these probabilities, what people are doing, essentially, they built a giant brain. They simulated a brain with a bunch of neurons, and they fed it the entirety of the internet into this brain, and they made it see and read all this text. And it took like, I think it is equivalent of like 300 GPU years or something like that if you were to train on a GPU, but they trained it on like over like 1,000 GPUs in parallel for 30 days straight. And it cost them like $5 million to train this neural network. But once it's trained, it's got this probabilistic model of language. So it's really cool. But at the end of the day, what it is, it's like it doesn't actually understand the words. It really understands the probability of, given these sequence of words, what is the next word. It's really not understanding. So this is what like Noam Chomsky like hates this type of stuff. He thinks it's not real, you know, because it's not real understanding according to him. It's more like it's just a bunch of probabilities. But, you know, like the people who sort of do this kind of stuff say, like, their retort is like, well, that's kind of what your brain does too. Your brain is just like figuring out these probabilities. So, you know, it's like a debate. But if you look at the other way, which is like the more Chomsky way, is that like he's essentially, you know, like we said, he's like a Platonic. So he doesn't believe in like looking at the world and looking at a bunch of data. He's almost like, what is the underlying rules of the world? Let's discover those rules and everything else will come after that. So he sort of looks at it. Next slide. So he sort of defines it as like, here's like the constituent parts of speech. Like, you know, speech has like nouns, verbs, prepositions, determinants, and you can sort of put them in different ways, you know, but there is like a very specific formalized way that we define. Like that's what like grammar is. So you say like, hey, a sentence should have like a noun phrase followed by a verb phrase. And what a noun phrase is, usually it can have a determinant, or maybe it doesn't have a determinant, but it always has a noun. And then maybe it has a preposition afterwards, you know? So you sort of define these set of steps, like essentially rules. And then when you get a new sentence, like the sentence, the dog likes ice cream, like you can essentially take this sentence, you can break it up and you can sort of build a tree from this, you know? Like you can say like, I saw the word the is a determinant. So the next word must be a noun. So it's a dog. And if it sort of doesn't match this expected syntax, it just rejects it. So that's kind of how the two different ways of thinking about language work. There's more, one is more like probabilistic and sort of like a lot of like chains. The other one's more like a hierarchical tree structure. And they both have their pros and cons, right? Like the tree structure is you have to annotate it. Like a human has to go in and tell the computer, these are the nouns, these are like the structures and all that stuff. But like, how do you even tell a computer what the structure of English is? Because English is not like, it's not like some guy sat and like figured out the rules of English. It sort of evolved over time. So it's like hard to formalize English because we as humans cannot come to a consensus on what English is. There's so many like ambiguities, like some words are both nouns and verbs, like how do you like even handle puns? Like it's really hard to define like a formal structure for English. So what we call English is context sensitive language, which means that like a word's meaning is dependent on the words before and after it. Like a word in isolation, some words have like, you can just sort of look at a word and figure out its meaning, but a lot of words mean different things based on what words are around it. So it's context sensitive. So these the method where you do with the trees, it really only works for context free, which means that like it doesn't need to know all the words before and after it. It only needs to know the words after it. So it's like you remove the ambiguity by removing the need for context. So something like trees work really well. So most of like parsers and lexers and all of that kind of stuff uses this kind of like tree format to parse out like the source code. But most of things that deal with like context sensitive stuff that requires like understanding of language uses more like a probabilistic model. So you can see the trade-offs, right? The probabilistic models has really good attention, and attention essentially means that it has more context to the words, but really poor understanding. And this model has really poor attention, but really good understanding. So it's like, it's kind of the trade-off between Platonic and the sort of Aristotelian, really. So I guess that's the final slide. This is kind of where what everything's been leading up to. Like, what is the Chomsky hierarchy? Chomsky essentially created this hierarchy of grammars, and it's kind of like a Matryoshka doll. Like a type 2 has all the powers of a type 3, and a type 1 has all the powers of a 2 and a 3. So like a type 1 and a type 0 are essentially the same. And what they essentially mean is that like you can have a grammar and that grammar would have an equivalent Turing machine, which is that like if you have like a language and you're trying to figure out the meaning of a word in like English language, which is context sensitive, and you have to essentially, to figure out the context of a word, you have to like look at all the words around it. That is sort of covered in type 0 and type 1. The problem with that is that like you don't know when to stop. Like how far do you go before you stop and say like, okay, I know what the context of this word is. It's really hard to know because English is recursive. Like the rules in English can sort of reference themselves, and it could be a recursive thing. So you don't know when the program will halt. And, you know, it's a good thing if you program, you know, when it halts. So you sort of run into the halting problem. So it could either take, you know, like exponential time to finish, or it could just never finish because it just keeps searching. And it's because computers really don't know when they're stuck in a loop. So that's like type 1 and type 0. And as we said, like this is mostly used in the academic realm. Like you don't really see this in practice. This is more for like the theoreticals, the platonics to sort of play with. But it really gets useful after type 2 and type 3. So type 2 is like the context-free grammar. And we just talked about this in the last slide, which is that instead of saying that the context depends on either side, you sort of pin one side and so the context only depends on one side. So your data structure becomes easier to manage. All you have is now a stack because you just sort of like pop new stuff on the stack. And when you want to remove elements, you can't remove this because you're pinned on one side. You can just remove from the top. So you have some guarantees around computability. You know when it's going to finish. You know that if you give it a program, it'll parse it in polynomial time. So that's type 2, and that's basically every single programming language. And then there's type 3. Like, what if you want guarantees on compute, but you also want guarantees around memory? You know, like if you add like a lot of constraints around it, that's what you get type 3, which is that the entire state of the program is baked into the program itself. There is no need for like thinking. So the program, it's like this thing. It's like it's like this sort of Markov chain over here, where if you're in a certain state, if you're in this state of, like you know that the only other states you can go to is courage, and love. Like there's no other states. And you don't actually know how you got to of. You could have come from like any of these branches, but you don't care about that. You only care about it in the future. So this is kind of what type 3 grammar sort of help formalize. And like a good example of this is like regex. Like regex is like a type 3 grammar. Or like if you go to like a vending machine and you know it's like a soda cost 30 cents and you put in like 25 cents, like the soda machine essentially has like an internal Markov, like it's like a state machine inside it. So it now goes from like 0 to 25 cents. And the only other state that can go to is like 10 cents because the soda costs 30 cents. But if you put in like another 25 cents, you put too much money, it goes into an unexpected state. So it like just rejects your money back. So there is no need for the computer to look ahead or look forward. It just looks and makes a decision. So that's like the most restrictive form of grammar, but also the most restrictive form of computation. So that is really it. But I wanted to like recap. It's like we talked about a lot of stuff. You know, we talked about linguistics and what is the difference between syntax and semantics. Syntax is all about the structure and the formalization of the language. It's not about the correctness of the language. Like I ate cake on my birthday is syntactically correct and semantically correct, but the cake ate me on my birthday is syntactically correct, but maybe not semantically correct. So it's like important to know the nuance. And most of what we talked about just deals with the syntactic nature of it. And the other big thing that we talked about was that it's like all humans, we have knowledge in us, and it's bestowed upon us, and we don't need to do anything about it. Like you are already as articulate as Shakespeare was. That's kind of the takeaway. And then we talked about like the Chomsky hierarchy, which is like this stuff, like this concentric circles. And like the big takeaway from that is that there is an equivalence between grammar and automaton. Like there's an equivalence between language and computation. And that's kind of cool because like when we're speaking, the language we use is to describe the computation that goes in our head, right? Like you already compute something and then you use language to describe it. So it's kind of cool to see that, you know, being replicated, in math. So it's like the equivalence between grammar and automaton. It's like the more constrictive your grammar is, the more constrictive your computation is. And then we talked about the two different ways, the chains and the trees. The chain method is more for like the stochastic method. It's good for like context grammar because it depends on the context of the words before and after it. And the rule-based methods are really good for parsing context-free grammar, kind of like programming languages. So you got to know when to use what. And then finally, we did a little bit of philosophy. We talked about Platonics and Aristotelians and the eternal war between them. So I guess, you know, it'd be good to figure out how we each saw the world. There'll be more. we can figure out how to work together. So yeah, that's kind of my talk. I don't know if you guys have any questions. Wow, 25 minutes on the mark.
Hey guys, I don't know if there's like a setting I messed up, but if you can't unmute yourself, let me know. If you can, feel free to unmute yourself and ask questions or type in the chat. I can start off by, is this more of a theory, or did he also prescribe how you should get there for each type? For example, like type 3 is more like, recursive descent parsers and abstract syntax trees, all that kind of stuff. Like, is there like also prescription how you should sort of go about, like, here's the interface to handle type 2, type 3, whatever? Or is it more like, okay, whatever you come up with is probably just going to fit into one of these 4?
Yeah, he did kind of prescribe like how to sort of model the problem too. Like you can see like for like type 3, he's like use a finite state machine. For like type 2, use like a push down automata, like a stack. And like for type 0 and type 1, you need like a double-sided queue. So like he does prescribe like the data structures to use to solve these problems. And then like even if you don't use this, like, I mean, there's like no other way to solve this but this. It's like, that's the nice thing about theory and sort of the Platonic ideals is like, this is it. Like they sort of define it. There's no other way, edge case you're going to find that doesn't fit into one of these boxes. Is that going to answer your question?
Yes. Jonathan, you want to unmute yourself? I don't know what you're asking.
You got to read that, Jonathan. I don't even know what those words mean.
Exogenous. Okay. I don't know what that setting is.
Xenolinguist. Any xenolinguist just making up languages to stump Chomsky and his ilk. I suppose they come from a structured background as well. So it'd be reasonably easy to decode. I don't know. I can't tell if it's a troll question or a real question.
It's a real question. I mean, there's enough people making up languages at any given moment. I mean, it's mostly BS like Tolkien, but
yeah,
like, is anyone trying to make languages to stump these assumptions, or is the fact that we're all coming from sort of the shared background?
Yeah, it's like the fact that we're human and we make the language, even if it's made up, still limits us to the humanity that we're bound by, I think. I mean, it sounds right. I might be wrong.
Fair enough.
Oh God, Dr. Gashler asked a question. Dr. Gashler.
Hey, this is a precursor to his own topic.
Do you have any thoughts on how language affects thinking? For example, suppose we systematically made English less context sensitive. Do you imagine that we'd push us to be less Platonic and more Aristotelian? Oh my God, that's such a good question. I was reading about this. So there's something called the Sapir-Whorf hypothesis, Sapirworf. And essentially what that says is that language, and it was a social studies experiment basically, and they studied a bunch of cultures and people, and they found that the thinking of the people was affected by the language that they spoke. So it definitely does affect it, because language and computation are so closely related that it's absolutely true. Feral children miss social development, which causes them to be unable to learn languages. Yeah, I think there is like a period, like from what I understood Chomsky's like really hard to understand because he like mumbles all the time and is like, he's just not clear, or like it's just hard to understand him. But from what I understand is that like there is you're born with this universal grammar inside you, and then when you're exposed to the world, it almost like tweaks it. It's almost like it like molds it for that thing. Like if you're born with it and you're exposed to Chinese, it's sort of like your ears and your language processor tune in for that. But if you don't hear it, then you permanently lose that ability for that part of the language. So that's kind of how I understood it. So maybe that sort of like explains what you're talking about too. Like if they miss that window, maybe some parts of it gets harder to reach or inaccessible. I don't know. Like Newspeak from 1984. Yeah.
Is there like what's the closest thing to a type 0 implementation in the academic or the real world?
I don't think type 0 and type 1 is like is real. I mean, there's lots of people who try to do it. Like essentially it's like a part of speech tagging problem. And there's a lot of heuristical methods to get part of speech tagging done through like, they do through like reinforcement learning or neural nets or whatever. But it's just like, it's not like for type 2 and type 3, you get like guarantees. You get like compute guarantee, you get a memory guarantee. Type 0 and type 1 is very fuzzy. It's more like engineering and not science. So yeah, in the scientific realm, it's like really hard. It's really hard. It's mostly they just use it for study. There's no practice in type 0 and type 1. Most of the practice are usually implemented as like stochastic models.
There's this thing like, well, who knows how much of this will be actually happen, but like Elon talks about with his Neuralink, there is a possibility in the future where you can actually share your brain in a super compressed way to the other brain. I don't know. I don't think that's more of a consciousness, but like we don't understand the brain, but we have a way to capture the movements from it and somehow pass it to another person. Like, I don't know where that would fit, but that's like a whole different thing.
Yeah, I remember Elon talking about this. Is like he sort of says like it's a text and voice is very low bandwidth because I got to think about it and then I can make these guttural sounds and then you got to hear it over voice and decode it, and there might be a lot of information lost in the dimensionality reduction and expansion. So it's like, what if you just connect my mind with your mind and we can just like beam thoughts to each other with like super high fidelity? I don't know. It seems cool. I don't know if it's like feasible or not, but it sounds super cool for sure. What'll happen if that happens is that we'll kind of blend into the same person because I wouldn't know which thought is mine and which thought is yours. We will just become like the Borg. That'll be cool.